The next interesting tool is Keras. It's an API designed for human beings, not for the machines. It's a human-friendly API. Keras follows best practices for reducing the cognitive load. It offers consistent and simple APIs. It minimizes the number of user actions required for common use cases and provides clear and actionable error messages. So through this consistent and simple APIs, the cognitive load of the humans reduced, minimizes the number of user actions. So very few actions are required by the human. So a high level abstraction is created by the Keras, and it has extensive documentation and developer guides, so that will help even the beginners to get in and work more efficiently. Keras is built on top of TensorFlow 2. Is an industry strength framework that can scale to large clusters of GPUs or an entire TPU pod. It's not only possible, but it's easy also. Keras take advantage of full deployment capabilities of the TensorFlow platform. So we can export Keras models to JavaScript to run directly on the browser, to TensorFlow Lite to run on the iOS or Android and embedded devices. It's also easy to serve Keras models via web APIs. Keras is a central part of tightly connected Tensor2 ecosystem, covering every step of machine learning workflow, from data management to hyperparameter training to deployment solutions. Keras is very famous, and it's used by CERN, NASA, NIH, and many more scientific organizations all around the world. Keras has a low-level flexibility to implement arbitrary research ideas while offering optional high-level convenience features to speed up the experimental cycle. So when we are experimenting, it provides us convenient features, so that way we can speed up our experiments. So because of its ease of use and focus on user experience, Keras is the deep learning solution of choice for many university courses. It is widely recommended as one of the best ways to learn deep learning. So that's an example how Keras can be used. So a Keras deep network is defined in multiple layers of neural network. So one layer here is showing the image of 28 by 28 pixels, and then that image is convoluted, and we get 8 copies of 26 by 26 size, and then we use a max pool here, so that reduces the size of 26 by 26 to 13 by 13. So here 8 is a number of features used for internal activity, and finally a sort max is applied, and that will produce uh, 10 outputs. That's representing probability of being one of the 10 outputs. So looking at this, we can simply use for classification. So this example shown here may be using for classifying one of the 10 objects. So maybe 10 numeric characters 0 to 9. So 0 to 9 are presented in the form of image 28 by 28 pixels, and then through this model, so it is trying to classify so what the particular digit is, or it may be talking about 10 different objects in the image and maybe trying to identify which of the objects is being shown in the image. So that's just an example. So we have a very big future for Keras. So it can be used for hundreds of layers of neural network. So 50 layers, 100 layers, 500 layers are some examples. So when it comes to working with 50 layers or 100 layers of data, then definitely it needs to be a very fast. So it's one option is to train this, and we need it to be done very fast. Other option is we can make use of a pre-trained model, and then the last layer can be replaced with another layer and use the pre-trained model for another purpose. So just as in the case it's discussed in this example, one model may be available for showing classifying the images of various maybe different types of animals or birds. So 10 types of birds were there in the picture, and this model is trained to identify which bird is there currently on the picture. Then instead of classifying the birds, we can classify, say, numeric digits. Then the whole, instead of building the whole deep network again, we can use this already trained model, and only thing is the last layer you modify. So in the first place, when it was shown say a sparrow, then one of the 10 outputs was going high, others were low. Now when a digit 1 is shown, then maybe the one which was getting high for sparrow is now getting high. So if we can see such a correlation, then yes, just the final labels we can change. In place of sparrow you can write 1, in place of crow you can write 2, and so on. The same model now will be working to classify the numerical digits instead of birds. So that's another advantage of Keras. That's a pre-built models are available. So some features of Keras, output of any intermediate layer is available. So that means we can use any particular intermediate layer as end of the neural network, and output of that can be diverted and used for other purpose. So we can have the Keras has a collection of large data set. So when you are trying to learn machine learning and all that, so when in this situation, if we use Keras, we don't need to search run around to search the data for our experimentation. Yes, large data set are available with the Keras, so we can make use of them. So we can train from the NumPy data. We can evaluate and predict using the Keras. Pre-trained models are available as discussed earlier. So you just try to select the best pre-trained model for our application, and with little changes, the pre-trained model can be trained for our application. So that way, a lot of time can be saved. Almost 99% of the time can be saved if we use appropriate pre-trained model available in Keras. Encoding in Keras is possible. Layers are there are very number of layers are there in the Keras. Modularity and Python native library is another feature of Keras. So all the Python library are useful or can be used by Keras. So we don't have to run around for translation if we are working on Python. So you can directly use through Keras and make the things even more faster. Pre-processing of data is very easy through Keras. So we can look at the Keras in multiple ways. So the core modules, APIs. So there are activation functions defined under Keras. There are optimizers available under Keras. Various loss functions are available. Various metrics for optimizing are available. Initializers, regularizers, various data sets available, and callback modules and visualization tools are available in the Keras. When it comes to model API, we have a sequential model, we have functional model, and then composed as layers. So core layer, locally connected layer, convolutional layer, recurrent layer, pooling layer are the various possibilities of building the deep network. So we can define layer wise. We can define sequentially or functionally, that is model wise, and each of these layers we need activations, optimizers, loss functions, metrics, initializers, callback modules. So if you work for some number of iterations, and on the way if best situation was found, then we can't go back there and get the thing. But through callback module, yes, it keeps remembering the best scenario on the way, and when you end the process, you can ask to get back to the place where the best results were available. So that situation can be further used as a model. Many visualization tools are available with Keras, so that makes the analysis of the data very much easier. So these are few advantages or the few features of working with Keras. The major advantage with working with Keras is built on top of TensorFlow. TensorFlow is built on top of Python. Therefore, all the features of Python and TensorFlow are used by Keras, and along with that, additional features also provided by Keras. So that's about Keras. Other tools will follow in the coming session. So keep watching.